Let's solve this homogeneous differential equation. Now, we have solved the differential equation 2xy plus x squared into y prime is equal to 3y squared plus 2xy. We want to solve this homogeneous differential equation. Now, first of all, I want you to see that this y prime is the same thing as the y dx. All right, solution. I want you to know that y prime is equivalent to the y dx. All right, so we have to make y prime the subject of formula, which is dy dx, to stand alone. All right, so we divide both sides by this. All right, we divide both sides by this so that y prime can stand alone, which is our dy dx. So it becomes 2xy plus x squared y prime is equal to 3y squared plus 2xy over 2xy plus x squared over 2xy plus x squared. So you note when you do that, you notice that this takes this away. So we are left with what? Y prime is equal to what? 3y squared plus 2xy over 2xy plus x squared. All right, which is the same thing as writing the y dx is going to be equal to what? 3y squared plus 2xy over 2xy plus x squared. All right, so let's continue from here. So we're going to make our what? Our substitutions. All right, we're going to make our substitutions. So recall that what? Y is equal to Vx. Now that you have made the y dx stand alone now, you recall your substitutions, the substitution that we make. And y is equal to Vx and the y dx is equal to V plus x dv dx. All right? All right? So now it becomes what? It becomes that what? The y dx now becomes V plus x dv dx. That is from here is equal to, I don't know if this space will be enough. All right, let's bring it down here. All right, let's continue from here. All right, now the y dx is going to be what? V plus x dv dx now is equal to, so anywhere we see y now, we replace it with what? Vx. So it becomes 3y, this is 3y squared, so it becomes 3 into bracket vx all squared plus 2x into bracket vx all over. Now, this is 2xy, that's 2x into bracket vx plus x squared. So this is going to be v plus x dv dx is equal to what? 3. This squared affects v and x, so it becomes v squared x squared plus, this multiplies this, you have 2vx squared over, now this multiplies this, you have what? 2vx squared plus x squared. All right, so now let's continue from here. Now from here we're going to have what? V plus x dv dx is equal to what? Now x squared is common up on both sides. All right, v is also common, but let's take the x. So x squared is common, so you have x squared into bracket what? 3v squared plus what? Plus 2v. All right, all over what? X squared is also common down, so you have x squared into bracket what? 2v plus 1. All right, 2v plus 1. So continue. So it becomes that this x squared takes away x squared, eliminates the other x squared. So we have v plus x dv dx equals to 3v squared plus 2v over 2v plus 1. All right, now the next thing, what do? We take v to this other side. All right, so now it becomes what? X dv dx is equal to 3v squared plus 2v over 2v plus 1 minus v over 1. All right? Now let's do our LCM. So it becomes x dv dx is equal to LCM of this and this is 2v plus 1. 2v plus 1 divided by 2v plus 1, that's 1. 1 times all this still gives us 3v squared plus 2v minus v into this divided by 1 is still this. So this would times this. So it becomes minus v multiplying 2v plus 1 because there's a minus v here. All right? Be conscious of your signs. It's very, very important. So x dv dx is going to be equal to what? 3v squared plus 2v. Then this multiplies this. We have what? Minus 2v squared. All right? And then this multiplies this. We have minus v over 2v plus 1. All right? So what are we going to have? We're going to have 3v squared minus 2v squared. That gives us v squared. So that will be x dv dx is equal to what? V squared. Then 2v minus v gives us what? Plus v, right? Over 2v plus 1. So now, what are we going to do? We are going to what? Separate the variables, all right? We're going to separate the variables. We're going to take anything v here and take everything x and dx to the what? To the right hand side. So we have to take all these guys down here and take these guys down here. So it means that for us to be able to take this guy here, we're going to multiply both sides by the inverse of this. So the inverse of v squared plus v over 2v plus 1 is the other way around. It's going to be 2v plus 1 over what? V squared plus v. Then also to take this x and this dx down here, we're going to multiply this side too by the inverse of this. X over dx, the inverse of x over dx is dx over x. So we're going to multiply both sides too by dx over x. So that's what we're going to do right away. So we multiply both sides by what? By dx over x, and also multiply both sides by 2v plus 1 over v squared plus v. That's the inverse of this x over dx, which is dx over x, and the inverse of v squared plus v over 2v plus 1, which is 2v plus 1 over v squared plus v. All right, so we'll have to rub this off. I hope you've written this down. All right, let's continue. So multiplying both sides by that, we're going to have what? We're going to have we're going to have dx over x multiplied by 2v plus 1 over v squared plus v multiplied by x dv over dx is equal to the same thing, multiplying that side too by, we have v squared plus v over 2v plus 1 here already. So we're multiplying it by dx over x, and we're also multiplying it by what? 2v plus 1 over v squared plus v. All right? So you see now that this eliminates this eliminates this here. And then you see that what? This eliminates this and this eliminates this. All right? So this is going to become what? You have this to become what? 2v plus 1 over v squared plus v with respect to dv is equal to, now you now have dx over x here, which you can also write as 1 over x dx. All right? So this is what we now have. All right? this is what we now have. So we are going to now integrate both sides. All right. So we're going to integrate both sides. So we integrate both sides. Integrate both sides. All right. We integrate both sides. So it becomes what? Integral of what? 2v plus 1 over v squared plus v with respect to dv is equal to integral of 1 over x with respect to dx. All right. Now, there is something about this kind of integral here. All right. There is something about this kind of integral. What do you notice about this integral? You notice something, that if you differentiate the denominator, you will get the numerator. Differentiate v squared, you have 2v. Differentiate v, you have 1. So this is the integral of the form that if you integrate f prime of x over f of x with respect to dx, your answer is going to be what? Ln f of x. What are we trying to say? We're trying to say that if you have a function whereby if you notice that if you differentiate the denominator, you have the numerator, your answer is going to be ln, all right, natural logarithm of f of x. That's ln of the denominator. All right. So we know that our answer already now is ln of v squared plus v if we integrate the whole of this. There's also a manual way, which I'm going to do for our audience that really want to understand how that comes about. But we know that the answer to this is what? Let me write it here. Is ln what? Ln v squared plus v. All right. And then if we integrate this, we have what? Ln what? X plus c. All right. This is established already. Now, hope you don't mind if I rub this off. Let me now show you how we can integrate this in the normal way. And you'll see that we still get this same answer, ln v squared plus v. All right. Let me walk you through that very quickly. Very quickly. All right. So we have integral of what? 2v plus 1 over v squared plus v with respect to dv. So what we can do is say let u be equal to v squared plus v. That's the denominator. All right. We say let u, or whatever alphabet you want to use, to be equal to this. I love using u. All right. So we differentiate. So du is going to be equal to, differentiate this. That's going to be 2v plus 1. Then you put dv by the side. It's supposed to be du dv, but if you cross multiply, it still comes here. Now make dv the substitute formula from here. Make dv the substitute formula from here. Becomes du over 2v plus 1. All right. So that becomes integral of what? Integral of 2v plus 1 over, you told us let this be u. So this is now u multiplied by dv is what? Du over 2v plus 1. All right. So you notice that this eliminates this. All right. So we're going to be left with what? Integral of what? Du over u, which is still the same thing as writing integral of 1 over u du. And if you integrate this, you're going to have ln u plus your constant of integration. So when you recall that your u initially you said to be v squared plus v. Now you now notice that you now have ln what? V squared plus v as your answer plus your constant. So can you see? So just know, when you know the formula, that what? That if you integrate a function f prime of x over f of x with respect to dx, and you notice your integral is in this form, your answer will simply be ln of f of x. All right. That's what it's going to be. Ln of f of x. That's what you are going to have. All right. So this is this. So now we have this here. All right. So now that we've gotten this, now we are going to do something. This c, we are going to write it as ln c. So it becomes ln, this is v squared plus v is equal to ln x. I can also write this c because it's a constant as ln c. According to the law of logarithm, all right, that if you have log what? A base x plus log b base x, because of the plus, they can come together and become 1. So A and B multiply themselves to base x. So it's equal to A times B gives us log A, B base x. So for this, according to the law of logarithm, we can bring them together because of this plus and multiply this and this into one logarithm. So it becomes ln v squared plus v is equal to ln cx. All right, let me put it in brackets, ln cx. All right, now because we have ln on both sides, all right, they can cancel themselves. All right, now we have ln on both sides, they can cancel themselves. So we now have v squared plus v is equal to what? Cx. All right, is equal to what? Cx. Now I want you to recall that y is equal to vx. So if y is equal to vx, we know that therefore v is equal to y over x. All right, so we have to write our final answer here. All right, so this was just to show the integral of this. So we have to rub it off. I hope you've written it. You can pause the video, you take the video back, watch it, understand it, so that you get to, anytime you see a question like that, you know what to do. Or an integral like that, you know what to do. So now let's continue. So it becomes v is equal to y over x. So it becomes what? Now it becomes what? Y over x all squared. That's putting this here plus y over x is equal to cx. So this square affects this and this becomes y squared over x squared plus y over x is equal to cx. All right, now I can multiply through by x squared. All right, multiply through by x squared to remove these fractions here. Multiply through by x squared. So it becomes x squared multiplied by y squared over x squared plus x squared multiplied by y over x is equal to x squared multiplied by cx. So this x squared takes away this x squared now. So we're left with what? Y squared is equal to what? Now, 1x takes away 1x here. So you're left with one of it here. So you have what? Xy is equal to what? This multiply this, you have what? Cx to the power of what? 3. All right. So this is the solution. Oh, sorry. This is not equal to, this is plus. So you have y squared plus xy is equal to cx to the power of 3. So this is the solution to our differential equation. To this differential equation, this is our solution. Now make sure you like this video, share this video, and hit the subscribe button. And also watch the videos, more videos that I'll be uploading on this. Make sure you watch it.